So today we will be talking about some basic C++, um, and just go over the basics. Hopefully this should allow you to code something, do some very simple stuff. So there's many programming languages out there, and of course, this C++ is one of them. And there's a few reasons for choosing C++ over something else like Python or Java. So, um, it's very powerful and it's like very fast. So sometimes in like competitive programming, like if you write a code in Python, sometimes they'll give you twice the time to solve the same problem because Python is just that slow. Or maybe I should say C++ is just that fast. Um, and it's the best for competitive programming for the same reason. And you can also code many games with it, such as like there's a lot of Nintendo games and like Genshin Impact, which some of you may know is coded in C++. Um, and but like of course there's reasons to use other programming languages. For example, if you're doing machine learning, you would want to use Python because Python is has like more machine learning algorithms, libraries and stuff. So now we'll get to some basic C++ stuff. So I will be using Replit for this class, and I've opened up a Replit program here. I've just like opened one up, and then this is like just here by default. So let's start by unpacking these 5 lines, or 4 technically. So the first line is include IOStream. What this basically does is include is kind of like import in Python if you know some Python. And basically what it does is that this IOStream is called a library, and then um and basically it has a lot of features um that are built in if you include it. So IOStream specifically is for inputting and outputting. So this is the main function. It says main. And we will talk about functions later, but um yeah, we'll talk about functions later. So what you need to know for now is that main is like the driver class, and pretty much when you run the code, it starts from main. So if you have another function, it won't start with that. Um so this is the first line in C++, in our C++ program. So um STD is we kind of want to ignore that. So I'm gonna do this. So you don't really need to know what this does, but basically STD helps. It's it's like I'm not sure how to explain it, but like you don't really need to know for now. So like if you don't include this, you would have to do STD cout. You would also have to do STD like other stuff, like insert stuff here. I don't use things without STD, so yeah. And then this is basically uh like it signals to the computer that it should print this now, and don't worry about this. So then this is a string which we'll get into, but it prints out hello world. And at the end of this line, there is a semicolon, which you will need for statements. So if I run it, you can see it says hello world. Um, yeah, and definitely make sure to remember the semicolons. Um, like if, for example, if you use Python, you will not need semicolons, but hopefully it will become such second nature to you as you program more in C++ or Java, which also uses it. Um, yeah, and the main function, as I said, we will be getting into that later. You do need these curly braces, but that's not too important right now. So now we'll talk about comments. So for example, we can do this. And this double forward slash basically signals to the computer that this is a comment. And comments are really useful in that they they have like two purposes. Firstly, it just obviously it tells you what it's going to do. And here, I think most experienced programmers will know what this does. But if you're writing something really complicated, comments are really useful to um help other programmers who are reading your code understand it. But also like if you're looking at previous code that you wrote, you would also want to look at like you might want to look at your comments to understand what's going on. And another purpose, which isn't like which is more common at the higher levels of programming, is that you can comment out like sections of code. So if a section of your code isn't working, uh, and you want to try something else, you can if you delete it, like you can undo, but that might take a while. So commenting out your code is also something that's important. So for example, I can do this, put two forward slashes, and then now nothing should print out. Yeah, nothing should happen. And you can also have multi-line comments. So uh it is it starts with this forward slash star or asterisk, and then you end like that. So this is multiple lines. This this also doesn't print out anything because it's in this comment. And multi-line comments are also quite useful. All right, so statements are basically like lines of code. To put it simply, like this is a statement. You can say like I don't want to get too complex with this, but once we start talking about variables, we can do like this. This is a statement. So like pretty much like most of your code will be statements because that's how um like that's pretty much how things how the computer runs the code. And so yeah, we'll be doing mostly like input and output comments. And I should introduce how to do input, but I will do that later. And there are variable like most of the time you will be doing variable related statements because variables are like incredibly useful. And this I will be teaching next class. Okay, so now let's get into variables. There's multiple types of variables. So types of variables. So there's int. Oh yay, AI helps me. Okay, yes. Maybe we'll talk about that. Okay, so these are the variable types we will be talking about. Int. Um, oh, and also you will realize that if you code Python, for example, you won't need it. You won't need variable types. So you can just do like hello equals. This is bad naming, but yeah, in C++, you'll see there's like a red squiggly line, which indicates that you cannot do this. So you will need, like, for example, right, I'm going to change this to a number. Int is the first one we'll go over. So how you declare a oops, a variable is basically you have the variable type, and then you have the variable name, and then equals, and then something. You could also do this, and so this is, remember, this is how we print something out using cout and this. I actually don't know what it's called, but this operator. And when we run it, what do you guys think will, let's start with this. What will this print out? Hopefully everybody should know this. You can type it in chat or say it out loud. Yes, yes. You all are very smart. It prints out 5. Okay. But so that's pretty straightforward. But what if we do this? What do you guys think it will print out? Um, Alexander, this is C++. Uh, I don't think C plus or C minus exists, but C sharp does, and C definitely does. So Elaine is correct. Does anyone else want to try and see, like, guess what it might be? I guess not. Okay. So Elaine is correct. It will, huh, interesting. Okay. I think this is a problem with the compiler, but it depends on what compiler you use. But normally, I think this would have printed a random. This should have been a random number. I believe the compiler is. Yeah, I think it's a compiler problem. And I will get into this tomorrow too, but um, does anyone want to see what this does? Does anybody have a guess? Uh, no, so this actually is not undefined. Um, okay, yeah, looks like nobody else has any guesses. So I believe this should actually be zero. And the reason is because this is a sure, let's have the AI explain. No, I'm just kidding. This is because this is a global variable and we will get into that later tomorrow. So this is pretty much all you need to know for ints, kind of, not really. So if you have like, I'm just gonna call it A for now. So one big problem, I guess, or limitation with coding is that you can have like there's limits in terms of like sometimes it's memory, sometimes it's time, most like so there is a memory limit for integers. So if you do something like this, um, does this work? No, it doesn't actually. Yeah, so if you have this, this will work properly. But if you have add another zero, does anyone have any guesses for what will happen? Um, so it is not going to be an error message. Alan is correct. It will overflow, but what will be printed out? Or will anything be printed out? Okay, so what happens when you run it is this compiler is really, really strange. Okay. Apparently Elaine is right. This does give an error message. Huh. Yeah, this compiler is very strange. It should have given a negative number, and the reason is because once it gets to the maximum positive integer, it should go all the way back to the negative, like the smallest integer. It should have been like a negative and a really, really large number. But apparently this compiler is very strange. All right. Okay, so what we do in this case is we use a long long, or you can call it a long, but I think long long is like best for like machine compatibility if you want to like share code in between like different machines and compilers and stuff. So now this will work because it what long long does is like it just has more memory. It's basically a bit in but a lot bigger. So um so the minimum of int, so int goes from 2, so it's actually from 2 to the 30, okay, negative 2 to the 31, all the way to 2 to the 31 minus 1. And, sorry, it should be this. Hopefully you all know what that means. So basically the lower bound is negative 2 to the 31, and it includes that number. This is the upper bound is 2 to the 31, and it does not include that number. So the highest would be 2 to the 31 minus 1. And the reason for that is because of binary, like 2's complement. And we won't be getting into that, but if you're curious, you can search that up. So next we have a float. And floats are very important because integers, which you may have learned from math, are like integers. They're not decimals. So if you have like in a equals 3.5, oh no, that doesn't work. And I'm really curious. Yeah, okay. So this gives a compiling error because 3.5 is not an integer. So in this case, we would want to use a float. And then if you use a float, it should work. Yes, it prints out 3.5. And let me clear this. Hopefully I can do that. Yeah, I can clear it. So floats, yeah, floats are like pretty much useful. You can do this and it will be 3.5. But we usually use double. And what double does is that with floats, there should be like similar to integers, there's like a memory limit. So if you have this, for example, actually this might always round, but like it can't be very precise. And so normally we would want to use a double for, like, for example, if you had like 5 divided by 7, like um it's a non-terminating, like it doesn't terminate, so it keep going on and going on. So when you use a float, you're cutting a lot of that precision. And then once you do more operations with that, it gets more inaccurate and it just keeps getting more inaccurate. And that's not very good. So that's why we use a double and instead of a float for most of the time. Unless you're like on a really, really, really small computer, then you would want to use a float. But this should give whatever 5. Oh, right. I tricked myself. Okay, so this gives 0, which is not 5/7. And does anyone have a clue why that is? Um, what do you mean by that, Elaine? 5/7 is, what do you mean by like that? Okay, so the reason it's 0 is because what the computer does is that it evaluates the right-hand side and then assigns it to the left-hand side. So when you do 5/7, the computer will be like, hey, 5/7, that's a 0. Because what if you have this, uh, this is it will round down or it will take the floor, so this will be 0. But if you but even if you do this and put a double, it evaluates this first, which will make it a 0, and then it puts it into A. And 0 is a double because all decimals, because all integers are like are doubles. All ins are doubles. So you can do this. So does anyone know what we would do in this situation to get what 5/7 actually is, which is like 0.71 something? Okay, so what we do here is um what do you mean by that, Elaine? So these are integers. This is a double. Uh, I'm not sure what you mean by that. Oh, so there's a few ways to like tackle this problem. So the first one is you can do, okay, you can just do 5.0 divided by 7.0, and this would give you the right answer because what the computer does is, sorry, this is 5.0, which is a double. Because it can't be an int, so it must be because it has a decimal. So it just interprets this as a double, and then if you have a double divided by a double, it's a double. But you can also do this. You can just make one of them a double, and that would work as well. So this, for example, would also give you 0.714. And the third way to fix this is by doing this, which is what's called like casting to like a different type. So basically what this is like, oh, there's a 5. Um, yeah, let's make this a double. That's basically what happens. And then um what happens is like if you put like if you try to convert this into something that it can't convert to, for example, bool, which we'll talk about later, like it just won't work. So it has to stay a double. And this should also give you 0.714. So here's a question for you all. Does this work? Okay, no. Why does this not work? Um, okay, so oh, you did it. Okay, I'm not sure like what you mean by like it solves this. Oh, yeah, yeah. Okay, yeah, yeah. It solves this first. So basically the reason is because it solves 5 over 7 first before it converts it to a double. So if we did not have the parentheses, then it would be the same as this, where we would turn the 5 into a double first and then divide it. But if we do this, we divide it first and then convert it to a double. And this would still be 0 because both of these are interpreted as integers. So does anyone have questions on that? No? Okay. So next we will get into strings. So similar to other data variable types, we can do string s equals hello. So here with the string we need this quotation, the quotation marks. And the reason is because if you do something like this, sorry, this will not work. And the reason is because the computer thinks that it's a variable. So, for example, like, what if we had this? Now, like, this is this 5 or is this hello? So that's why the developers were like, hey, we can put quotations around this. So now it's just hello. And then how would we print this? You can type it in the chat. Yes, Elaine, you're correct. This is correct. Don't do this because again, this will be interpreted as a variable. So this does not work. Um, you can do this, but like then what's the point of using a variable? So yes, CLS is the correct answer. All right. And then lastly we have Boolean. So Boolean is basically just like true or false. So if you have like a Boolean A equals true, you can do true. Then so this would be true and then this would be false. This would be false. And basically you can see that true printed out one and false printed out zero. And that's just how the computer interprets it. So you can actually do bool A equals zero. And this would mean false. So I will do something which you may not understand. But let's do that. So this is basically saying or not. Um, wait, let me clear this. So this basically says is A equal to false, and then it prints out one, which is true. So you can see that like zero is false and one is true. And yeah, that is it with all of the variable types. Um, and yeah, this is just defining a variable data. So data type, variable name, semicolon. You can do this or you can do this. Sorry, this. And by the way, with variables, don't do this. Let's, let's- like just don't. Why? Don't have very long variable names. It doesn't hurt. It doesn't help anyone. It hurts everyone's eyes and probably your hands as well. Um, and we also talked about local variables and global variables, how this one is initialized to for ints and doubles it's zero, and then for strings it's actually empty string, which uh we can actually test. So if you have this, this will actually be an empty string as well. So I guess there's no difference here. It's the same output, which is nothing. All right, and this is integer overflow. You can see like 10 to the 12 definitely would not work. And yeah, this is what I meant by like when it overflows, it becomes a negative number. So you can see on the slide, it becomes so the minimum. So the first value here is the maximum value, and this is equal to 2 to the 31 minus 1. And the second one is negative 2 to the 31. And you can check that if you want. And then with 10 to the 12th, yeah, you can see it becomes a very large negative value. Basically, it goes from positive, the largest positive value to the smallest negative value. And that's basically how integer works. And then long is basically the solution to that. Um, and yeah, this is floats and doubles. Obviously, you can do negative values. That should kind of be a given by now. And yeah, and we talked about why we use doubles and floats. So now strings, here is a problem for you all. I'll give you like 5 minutes to do this. Or so like Um, right. Okay. So for this, I will need to introduce. So you see, this is outputting, and I will add something here. This is how you, why is S? Oh, S is defined. So what end L does is it basically gives a new line. So if you wanted to do this, sure, let's use S again. So if you did this, you can see that hello are on new line on different lines, but this one it would be on the same line, and this looks quite ugly. So that's why you want to sorry. Usually you would want to yeah, have endo just to give new lines. And then that's pretty much all you need to know for outputting. For inputting, um, obviously you need to have a variable first, and then what you do is cn to a, and you won't need to end line or anything because you're inputting, so there's no like end line you need to do. And basically this like puts the user input into a, so we can try that. I'm gonna comment this out. So when I run it, it's like waiting for my input, so I can enter like 5. And let's print that. And all right, I'll put in like 6 this time, and it prints out 6. So yeah, and I'll give you like 5 minutes to work on this problem. Basically, you just ask for their name and then print it out, which I have kind of already done. But this is like, hopefully you can get some practice out of this. And put it in the chat when you are done. All right, I've gotten a few answers. So, um, I will like give the solution now, I guess. Um, okay, so what we need to do is, um, what was the question again? Right. So we should ask the user for what their name is. So you can say, hello, user, what is your name? And I saw that someone used this, which basically just prints a new line, but I will be using this handle instead. Um, and then so now we will have string name, and then we will input whatever the we will put whatever the user inputs into name. And then you can say, um, hello, name. And then this just pretty much, yes. So now you can see it says, hello, user, what is your name? My name is Ethan. Hello, Ethan. And yeah, that's basically all you need to do. So a few things I saw, or one thing I saw was someone did this, and I'm actually not sure if this works because like I usually don't put this unless I'm printing it, but let me see. Yeah, it does seem to work. So yeah, that's fine. You can do this. You can define a variable for this, or you can do what I did, which is just put the string literal here instead of using a variable. And also remember, uh, oh, never mind. You fixed it. That's nice. Okay. So yeah, that's pretty much the code. And then does anyone have questions on this? It's okay to ask. This is the first class. All right. There's no questions. Here is just a problem to recap. I'll give you like say like 10 minutes because I think 5 minutes was pretty good for the last one. Oh, by the way, something else you all should do when you're coding is obviously like test it out before like submitting it to like if you're doing competitive programming. You should always like use some test cases to check if like use multiple test cases to check um if your code is working properly. And you can also like test certain parts of the code, but I won't like get into that too much. Um, Helen, I think you missed like pretty much everything. Um, what do you mean by like, is there a link to access the C++ website? So like if you want to like code C++, you can go to like Replit and like sign up for an account, and then if you click create REPL and then C++, you can create this. You can also use IDEs, but I think Replit should be simplest. And there is a website to the reference, which you can just search CPP reference and it comes up here.
Excuse me,
Yeah.
do you have a website for the C++?
Like what do you mean by that? Like to code C++? Like the C++?
Yeah.
So go to Replit, so repl.it. I'll paste the link in the chat. So if you go here and then you sign up for after you sign up for an account, oh wait, give me a second. Yeah, after you sign up for an account, you click on the top left, create REPL, and then you click C++, and then you create REPL, and then wait a bit, and then it should be here, and you can start programming some stuff. Hmm. Oh, it's a few past. I've Okay, I will start explaining soon. Give me a minute. Okay, yeah, I'll start explaining how to do this. So, first of all, you'll need to ask the user for um their is your English score, for example. So you can and then end L for a new line. So you can technically put it all together, like what is your English, math, and science score, but that's not like I guess it would be easier if you did it this way, like easier to read. So we'll do in English. So I saw someone doing like string English and then converting the string to an integer. That works as well, but like just use int. There's no need to do the like conversions. So begin in and then cn. So this will put the input to the English score here, and then we can do the same. Gonna shorthand this. Okay, so now we have all of their scores, so we just have to calculate the average score. And so you could do this. And if you did this, you would unfortunately be wrong. And let me clear the console. So this looks right at first, right? Like, of course, we just like add it and then divide by 3. That's how you take the average. But there's a little problem. Like, let's say we did 100, 100, 100. Like, this works correctly. 100, 100, 90, 80. It's 90. That looks right. But what if you have like this? 90, 91, 91. Huh, that doesn't look right. The average is supposed to be, let me do math. 90.6 repeated, but that's not 90.6 repeated. So the reason that this happens is because you are adding these as integers. So we had these as integers. And then when you add it, this is an integer and 3 is an integer. So like integer over integer is integer. So there's a few ways you can there's a few ways to solve this. You can do this. As I said, you can convert one of them to double or a float, and that would work. And yeah, that works. Something else you can do is you do this. And you would think that this doesn't work because previously we did something like double, we did like double 5/7, and you might remember that this gave a 0. But in this case, we are doing the division here, not inside of the parentheses, so this works. A third thing you could do is change these all to double, and when you take the average, hopefully it will work. Yep, it does work. And yeah, so these are the ways to solve this problem. And I prefer this way because you might have like decimal scores as well. So if you have like a decimal score, then int wouldn't work because it would round down. So does anybody have questions for this? Okay. Looks like nobody has questions. So this is the end of the first day. I hope you all learned something and can code some C++ now. And like you can kind of see like just how powerful this is. Like we only learned about variables, but we can already like do this, which is quite impressive. So yeah, thank you all for being here, and I will see you tomorrow for the next class.
Bye. Thank
Bye.